So obviously I'm not in the building, but we'll kind of keep to the class schedule. I'll do 3 kind of newer material, but just more linear regression stuff this week, more examples of things we've already talked about. And then next week, we'll do some review. So I'll get some practice exams up there on Canvas today. A couple other things that I will get up there I wanted to show you. So let me see. I think I don't have yours set, but I'll get it together here. Here we go. So I'm going to put this Excel file up. Now this is for my other classes, so it's going to be a little bit different for you guys because you'll have some individual assignments, an individual assignment category as well. But if you go to Canvas, and you can kind of see what your grade is across all the Excel assignments. You can see what your average iClicker score is, your average Connect, Learn Smart, and then you guys will have your average individual assignment as well. So once you kind of get those all turned in and I get them graded, you'll know kind of what you can see in Canvas, what your scores are. So let's assume you had an 80 over the Excels, 90 iClicker, 90 Connect. Actually, we didn't do Learn Smart, so yours would be individual assignments, right? And maybe you did really well on those. You're then going to have how you perform in the first 2 exams. You could then kind of play around with, okay, how well on the final do I need to do? So kind of when I upload it, it will have some numbers in here, but you will essentially put whatever your numbers are, like these first, the different categories, and then the first 2 exams. You can then kind of play around with, well, if I get let's say I don't do well in the final here, well, if this is my scores, I would still end up with a C in the class. If I do really well in the final, it kind of bumps me up to that B. You can kind of play around with it. It basically, I have kind of these cells here, some functions that identifies what your highest, next highest, and next, middle and highest exam scores are. It then kind of uses all the weights for the different categories and would give you kind of what your expected grade would be from different hypothetical final exam grades. So I'll get kind of one up there for our course so that you can kind of start playing around with that. And then I also put up kind of the week 16 lectures up on Canvas today as well. So if we're looking at our course, we go down here, I'll kind of rename, all these are kind of linear regression. I'll kind of rename them so they specifically identify what types of subjects we're going over in these different lectures. And then the other thing that we'll be using today, I put up this PDF of a paper. So kind of like we went over that medical marijuana one last week, we're going to look at one kind of titled Information Matters. So that in mind. All right. Kind of just a reminder, since it's been a little bit, kind of hopefully everybody had a good kind of Thanksgiving break, a little bit of time off. When we're doing this linear regression, right, we had our y variable on the left-hand side and our x variables, right, we could include several of them on the right-hand side. So the interpretation became, for all of those different slope coefficients, right, those estimates of what the relationship was between the y and whatever x variable you're looking at, it's a 1-unit increase in the x variable would cause the predicted y value to go up or down by whatever that slope coefficient estimate was, holding everything else in the regression constant. So I'm going to walk through kind of a series of different regressions and different ideas, and maybe kind of think about how we would start to approach, I think, fairly interesting questions, and be able to come up with some answers to kind of better understand a specific set of questions and kind of show how powerful this regression output actually can be. So it might seem kind of trivial when I first start out with this, but it kind of paints a larger picture and just gives us a bunch of different examples of regression output we can interpret. So suppose if we look across major universities, they tend to they spend a lot of money on some of their athletic programs. So this kind of sparks a lot of controversy, in the sense that you're taking funds that would be used kind of for all students and you're pumping into this athletic program. Does it even matter? Like, are you actually even able to change the probability that you have success by spending more money on your athletic program, and what impacts might this have on kind of the university as a whole. So starting out, maybe we want to know, okay, there's this big tournament in basketball, right? The NCAA tournament, which makes, and I should probably look at that. I mean, no, I know it makes millions of dollars at this point. I don't know, probably it's a billion. I mean, they've got huge TV contracts. You know, they're selling out kind of arenas and probably, you know, really generating a lot of revenue, right, for the NCAA, which in turn gives, you know, this money back to all the schools that are involved, right? And so there's a lot of money to be made, and so these schools would like to make it into this tournament, get their name out there, be kind of one of the teams that's going to get some of the money from all this revenue generated. And so maybe we want to run this regression, right? So we've got a bunch of different universities. Like that's what our data set would look like. And for each university, we'll have whether or not they made it into the first round or whether they just made it into that NCAA tournament. So this would be a 0 if they don't make it, 1 if they do. And then we have kind of this X variable that we're thinking about, well, what can we influence, right, to make it in? Well, we can spend more money on this athletic basketball program, okay? So the interpretation of beta 1 here, right, is a $1 increase in our expenses would increase the probability of making it into that tournament, round 1 of that tournament, by whatever beta 1 is. Now, I said increase because intuitively we probably think if I'm spending more money on this program, you know, hopefully I'm getting better coaches, recruiting better players, and expecting it's probably a positive relationship, right? But if I'm thinking about what is, I think I have a thing in here, right? What would we expect maybe the sign and the size of that estimate to be? We can already explain, you know, the intuition is probably that it's positive, but if we think about the magnitude, right, remember it's a 1 unit increase, so it's $1 more. What's likely the effect of $1 more on increased success in the program? Probably pretty small, right? However, if I get the effect of $1, right, well, what if the team spent another $1,000 on their program? Well, we would just take that estimate and multiply it by 1,000, right? Or what's the effect if the team spends $1 million more in their program? Well, if this is the effect, beta 1's the effect of $1 more, multiply by 1 million, that's the effect of a million more. Now, if we're worried about kind of percentages or something, we might play around with, you know, looking at log specifications. But at least for kind of keeping it level, to get the effect of different sizes of increases in expenses, we'd simply take the effect of $1 and multiply it by whatever number of dollars we're interested in the effect of, right? So we have to remember, and you know, we don't need to understand every line of this. This is kind of the mathematical proof, but just a reminder that if we run this very simple linear regression, right, where we don't have any other control variables, well, what's probably true about schools that are spending more in their basketball programs? Probably likely to be larger schools, right, have a larger number of undergraduates, maybe more attractive kind of for recruiting top players. And so we might get an estimate for beta 1 that's very biased, right? So this estimate, kind of B star, we call it B hat, B star, our estimate is going to capture the true effect, but also this additional component, because we're leaving out, here I'm calling this X2, other variables that we didn't include in our regression that are kind of correlated with both Y and X1, the variable we included. So we can look at the results, but we have to probably think about, we want to include other control variables to hopefully kind of move, it was still evidence of correlations, not causation, but it starts to approach kind of an interpretation that we can think of as more causal, right? So here, what if I just include as another control variable the total number of undergraduates, right? So what might we expect to happen to beta 1? Well, before, it was capturing the effect of expenditures on the program, but also all these other variables were left out, such as undergraduate, like the size of the school. So once we're controlling for the size of the school, this is no longer capturing the effect of that omitted variable, because we've no longer omitted it, right? So here, if we look at this kind of final bias here, right? Well, if we have the variance of x1, that's always positive. The effect of whatever variable we left out on the y variable times whatever the correlation is, the covariance, between the variable we included and now this omitted variable. So before, when we left out total number of undergraduate enrollment, right, it's likely that variable is probably positively correlated with the expense variable, so positive and positive. And what would the effect likely be of the size of the school on our y variable, which was whether or not they may have kind of this athletic success? Well, that was probably positive as well. So our estimate before probably had this huge positive bias. So we would expect now, when we include and control for that x2 variable, the size that we now get for beta 1, the estimate, is probably going to go down. Right? So, we can kind of understand, what the sign of that bias would be if we think about the relationship that that variable we left out would have with the y variable, but also with that x1 variable that we had included, before, the one that we were kind of focused on and interested in originally. Okay. So I kind of explained this in words, but we're probably thinking before we would have had a positive bias, so our estimate would have been too large. Sure enough, now this is an Excel output. This is from a program called Stata. It looks a little bit different, but it still gives us our coefficients, our standard errors, our test statistics, and our p-values. So notice when I simply use that, whether or not they made it into the first round as my y variable, and basketball team expenses as my x variable, it's a pretty small coefficient, right? e to the -8. So move this 7 places to the left. But we would expect it to be small. It's the effect of $1 more, right? So if we want the effect of, say, $10,000 more, right, we would just take this coefficient and multiply it by 10,000. Now, if you notice, it's highly significant. The p-value is essentially 0. And what we always kind of start out with, let me see here, it's kind of minor. If I can get this marker to go. All right. Just kind of as a reminder, our null hypothesis for all these slope coefficients, so b or beta, however we notate it, is always that the relationship is 0. Right? So if we find a p-value that's really, really small, we can reject this. So with that p-value that was essentially 0, with any level of significance, we can reject the null and say that it's not possible for there to be no relationship between basketball expenses and having success, making it to that first round of the tournament. Right? We can reject this. Okay. So if we then look at what happens when we include this other variable that we think is probably an important omitted variable, which is kind of a control for the size of the school. We'll notice our coefficient, right, still pretty small, but it has went down, right? It's went down a little bit. And we also can kind of see that variable for undergraduate enrollment was probably an important control because the p-value is 0 there as well. So we can reject that there's no relationship between total kind of undergraduate size of the school and whether or not they have success. Also kind of evidenced by, if we notice, our r squared, the proportion of the variation that we see in the y variable that we explained before was 0.17, and now it's 0.18. Right? So we're explaining a little bit more of the variation in this y variable by including additional controls, which kind of makes sense, right? If I have more, I'm controlling for more factors, I'm able to kind of better understand or make better predictions about this y variable. Okay. Now, you don't have to worry about any of this stuff whenever we're kind of looking at the output. We're not doing anything with this information in this class. It's really focusing on that r squared, there it is, and then our coefficients and kind of our p-values, right, are really where we want to focus. Okay? Any questions on this before we keep moving? Make sure I can see there we go. Okay. So there's a pretty small estimate, right? But I kind of already mentioned, well, that's the effect of $1. So if I'm thinking about, on average, these schools are spending over $1 million, and the standard deviation is almost $2 million, it wouldn't be unreasonable for a team to maybe go up half a standard deviation, which would be $1 million, right? So we could start to think about what effect would this have for different increases in in basketball team expenses, right? So I kind of did, just a couple quick back of the envelope things. If I looked at kind of the average school in the top 100, they're on average spending 9 million. So 10% increase in their like budget for their basketball program would be just under $1 million. So the effect for them, if they increase their budget by 10% or $900,000, would be that 0.00000738 times, that was the effect of $1. So the effect of $935,000, just multiply that. So remember, when we have a y variable that's a 0 or 1, when we're thinking about changes in the predicted y value, in our actual data set, y is only ever a 0 or a 1. So when we're thinking about making predictions about this binary variable, we really can think about it as this is increases in the probability that y variable becomes a 1. Right? Or if we want to turn that into a percent, right, multiply by 100 and maybe the kind of percent increase when you think about in that y variable. So the probability of making the tournament, if you increased your budget by 10% and you were kind of in this top 100 schools, would be about 0.069, or increase your chances of making it into that tournament by about 6.9%. You could do this for different schools. So I did IU here. They're a little above the average. So a 10% increase in their budget would be 1.2 million. We could do schools like Ball State. A 10% increase in their budget is much smaller, so only 150,000. So we multiply 150. So 10% increases in a budget for different schools is going to have very different kind of effects, right? Because 10% for Ball State is a much lower amount of money than for IU. But this is just kind of the interesting things you can do with it, and think about, okay, well, if I can increase my chances of making it into this tournament by 10%, the expected payoff would be then 0.1 times however much money I get for being in that tournament. So, just to kind of round this out before we kind of move on to the next related regression, what else might we want to control for? I mean, we could throw the gambit, right? We could look for every single piece of information I could get. So maybe, did they make the tournament in the previous year? So we somehow control for kind of what their quality was. Previous wins, another control of quality. Well, look, if I'm increasing my expenses, it's because if I have higher revenues, I may be able to increase my expenses even more. So maybe this is an important omitted variable as well. So I can control for what the revenues those schools are making, what year it was. Maybe there was some years where, I don't know, you had, dominant players, or you had kind of a bad year for revenues. And so I might want to control for that as well. So to control for year, I just include a 1-0 variable for every single year. I then kind of include these additional control variables. And now I can see that when I look at that basketball team expenses, it's fallen by quite a bit. So before it was 0.000007, now it's 0.000002. Right? Still significant. The p-value is still kind of less than 0. Right? And now the interpretation is we're comparing more so apples to apples. So two schools that either both previously made the tournament or both previously didn't, same number of total undergraduates, same amount of revenue, same number of wins in the previous year, and we're looking at the same year for these schools, but one of them spends $1 more on their basketball program. What's the effect of that on whether or not they make the playoffs with this y variable? Not the playoffs, NCAA tournament, right? So as we include these additional controls, it just gives us a lot more power. Like our statement has a lot more weight, because we're really, this thought experiment is you're getting two otherwise like identical looking schools, but one of them spends $1 more on their program. What's that effect, right? So a lot more powerful when we can kind of include these additional control variables. And notice when we include some of this additional stuff, we've got our R squared up to about 0.3 now. So we're explaining now about 30% of the variation that exists in whether or not a team makes it to the playoff or not, or the NCAA tournament or not. Okay. And we could go through and kind of say, this is significant. It looks like total undergraduates, we no longer can reject the null for that variable. You can just use those p-values to make your rejection decisions. Any questions on that one? Also, kind of revisiting a discussion we had before, notice I included identifiers for each one of these years. So 2005, 6, 7, 8, 9, 10, 11, 12. Actually, this data, I believe I had up to 2013. So I left out, right? Whenever we have these identifiers that, you know, if I have data from 2005 to 2013, I can create an indicator variable, 1 or 0, for every single year, but I have to leave one of them out, right? So here I left out 2013. So relative to 2013, in 2012, your chances were about, what, 12% lower, right? Or probability was about 0.12 lower. Relative to 2013 and 2011, it was only 0.1 lower, right? So interpretation here is a little weird, just because it's kind of hard to think about, just existing or just having a team in that year. It changes kind of the probability of whether or not this was 0-1. But it's likely because, like, the number of schools that existed, or the number of basketball programs, or the number of high quality players might have varied across that time period. Okay. So we could do the exact same thing. I'm not going to spend a lot of time on this because it's kind of sports related, and I don't want to kill all of you with kind of these sports examples. We could do the same thing, right? But a 1-0 for whether or not they win the championship. So if we look at the effect there, it's like even smaller, right? I don't think I didn't put the output up there from Stata, but it's very, very small, right? I think there's actually another 0 in there. So now if I spend an additional $1 million, I'm only increasing my chances of winning that national championship by 0.39%, right? And $1 million increase would be very large for like a school like Ball State, right? So if Ball State increased it 150,000, they're only going to increase their chances by 0.059, which is so low that essentially you're wasting $150,000 probably. So the reason why I kind of started with this general idea of whether or not kind of increasing money into this athletic program can lead to success is because if it can, right, which we found, it does increase, where was it? Yeah, here. The likelihood you make it, right, into that tournament and potentially generate additional revenue. Well, if we know that, right, it could also then be, well, if I have success in this tournament, does that somehow positively impact my university, right? So I could think about, if a team makes it into this NCAA tournament, do they see the number of applications increase in the following year? So there's kind of been some work done on this, where the idea is that, so most of you are probably from Indiana. If I told you, let me think of a good example. So if I were to tell you, mention you Valparaiso University, I would guess a lot of you have either heard of it, or you might know where it's at in Indiana. If I told someone in California, where's Valparaiso University, my guess is they are going to have to use Google, right? And so they might not even be aware that it exists, right? So if somehow Valparaiso makes it into this NCAA tournament, and now, we could look up the number of people that fill out brackets, and the number of kind of screen time, even just the bracket gets, where you see, you don't even have to follow sports. If you just see that name, right? Like, what was it, the other couple of years ago, Loyola Marymount or whatever. I would have never heard of that school, but because that, they have success and their name is kind of all over the news, even if it's just general news, not just kind of sports related, well, you're getting your name. It's marketing. It's basically free advertisement, right? So maybe this has a positive impact. You see a higher number of applications. If I have more applications, even if I don't want to admit more students, I can now be pickier, right? If I have more applications, I'm going to have more students at every point in the kind of quality distribution. Someone's at the door. Hold on. All right. So we might see these positive impacts on the school, which, okay, well, now there's not just additional revenue to be made from making it into the tournament from the athletic side, but also from kind of the quality of my university. So I can think about my Y variable, right here being applications, and then I have an X variable of whether or not they previously made the tournament, okay? So here we can think about it as from writing this out. Okay. Oops. So I've got, oh, actually, that's not what I wanted. Looking at kind of applications. I'm looking at kind of round one, so whether they made it into the tournament or not, right? So now when I get a coefficient estimate here, a 1 unit increase in my x variable, well, this is just a 1 or a 0. So a 1 unit increase is going from not making the tournament to making it in. So this would be the expected change in the number of applications I get from making it into that tournament, right? And I can change this y variable and look at some other things as well, which we'll do here in just a second, okay? So let's look here. So we've got, I kind of ran this regression where my y variable is applications, my x variable is whether or not I made it, whether or not I was in the tournament the prior year. I dropped my marker cap, but I don't know where it went. So if I make it into the tournament, right, the expected increase in applications is about 7,300. That's how I could interpret that coefficient. Very significant, p-value 0, so it's significant at the 1, 5, and 10% level. But my thing about my omitted variable bias problem, I haven't controlled for anything else here. And we kind of already had a little bit of discussion, but it's likely that teams that make it into the tournament are more likely to be larger schools. So it's probably, this is just a correlation, right? Schools that have a higher number of applications probably were more likely to have a higher number of previous applications the year before, right? Which is correlated with being more likely to have a successful basketball. So we have included a lot of important control variables here. So one thing that I put in here is just, well, what was the previous number of applications the year before? Right, that seems like a really good control, because now I can think about, I'm looking at 2 schools. In the year prior, they had the same number of applications, but also in the prior year, one of them made it into the tournament. For that school that made it into the tournament, they would expect about 100 more applications the following year. Okay? Now, it's not quite significant here, but we've also, haven't included a lot of other control variables. But I also want to point out, notice, whether or not they made it into the tournament, we just had that as our x variable, our r squared was like 0.07, so we were only explaining 7% of the variation in applications. Well, if we include previous applications, notice we can now explain 97%. And that kind of makes sense. If we know how many applications they were getting in the prior year, that likely captures a lot of other factors about that school. And so now our predictions are going to be a lot more accurate. If I know the number of applications the school got the year before, hell, I could tell you they're going to get the exact same amount without doing anything, and that's probably going to be a decent prediction, right? So we've got a pretty high R squared by including that control variable. Okay. Oops. So we could then even do something that's kind of crazy, which is, well, look, I know that school size varies across states, right? If I look at schools in California, there's a lot of really big schools. If I look at schools in North Dakota, they're not near as large, right? So maybe I want to control for, and I mean, North Dakota schools are also just less likely to probably see as many applicants as schools in California. So I want to control for the state that these schools belong to as well. So all I did here, each one of these numbers represents a state. So this would be like Alabama, Arizona, so on and so forth. But now our interpretation of this coefficient on whether or not they made the tournament the prior year is, this is the effect, this is the increase in the number of applications from making that tournament for 2 schools in the same state receiving the same number of previous applications the year before. Okay? So, get about 167 more applications, pretty significant, right? With a p-value of 0.01, it's going to be less than 0.05 and 0.1, so significant at the 5 and 10% level, or the 90 and 95 confidence level, right? And our R squared is still going to be pretty high because we got these important controls. Okay? So it looks like having some success in that tournament is going to increase the number of applications you receive. Now, my guess is probably a better model. I don't know because I don't have it. Been running. I don't have the results here in front of me. But My guess is a log specification here might make a little more sense in terms of kind of the number of applications, right? Because, you know, if I'm a smaller school, 167 is going to be a much higher percent of whatever my kind of previous applications was, as opposed to, you know, a school who's receiving tens of thousands, you know. So we would probably want to use maybe a different model here, but just for the sake of kind of keeping it simple for today's discussion, kind of we use the level. Okay. So I did the same exact thing, and you could do it with or without those state identifiers here. I left them off, but it wouldn't change things very much. Now, if I look at not only the effect on applications, but if I have more applications, I can be a little bit choosier. Or maybe, you know, someone sees me, high quality students are more likely to become aware of some of these smaller kind of liberal arts schools that make it into the tournament who are able to provide a really high level of education. And so maybe they're not just seeing an increase in the number of applications, but that those applicants are coming from the higher end of the distribution. Or simply they could also just be more picky, right? The schools could, sorry. So now if I look at what's the effect of making the tournament the previous year on a university's kind of 75th percentile ACT score. So you could look at the average math score here and it'd be a very similar story. I kind of use the higher end just to make sure, like, are we seeing not just like a couple high quality students kind of influencing the average as much, kind of looking at more of that farther right tail of who I'm accepting. And you see if they make the tournament, holding constant the number of applications from the previous year, that a university who makes a tournament in the prior year, in the following year, their freshman class will have an ACT of about 1.5 points higher for that 75th kind of percentile cutoff, which is a pretty sizable increase, right, in the ACT score. Right? So, and that's very significant, right? P-value is 0 here. I did the same thing for English. You get a pretty similar effect, even a little bit higher there for English, still very significant. Now we're only explaining here about what 21 and 28% of the variation in that Y variable. So it's likely we're missing some important stuff, but this is a pretty interesting kind of first glance. Right? What else? Is this the same thing? English, math, yeah. So how large is this? Well, I mean, if we look at kind of the 75th percentile cutoffs for every university, they only range from 17 to 34. The standard deviation is about 3.5. So for making the tournament, right, if we go up here, that's increasing that 75th percent about 1.5, which is what? Just under half of a standard deviation, or here, I guess about a third, right? Somewhere between a third and half. So it's not that bad, right? A standard deviation, right, is a relatively large increase. And so here, being a third or even half of a standard deviation is a pretty sizable effect, okay? All right, any other questions on this before we kind of continue? I'm gonna go to that paper that I had posted for the rest of the discussion. We're okay? All right. So I have kind of some synopsis slides right here. I want to go to the actual paper. So here's a paper that was done. I saw this presented. It was pretty interesting. Like I said, this is how I usually look at papers. So they'll tell you all the stuff they did, which is great. But I scroll down until I find some equation, right? Because this basically tells me what regression they're going to run to try to understand the effect of something. Here, what they were going to try to do was they had two schools. Right? I believe in this, so I think it's Montana and Montana State, right? Make sure I'm not getting wrong on this. Yeah, so University of Montana and Montana State, right? And so they started sending out these letters, right, to these students that had some information about, if you take out this much money, it's going to take this long to kind of pay it off in terms of taking out student loans. And so this letter, actually, let's see, I think they have the actual letter at the end here. Here it is. All right, so they sent this letter out, right, at Montana State. and said, you know, you've accepted this, you know, whatever that specific student's amount of money that they've taken out, they've got that student loan debt. Interest rates are currently around this. So in order to kind of pay it off, or to remain in good financial aid standing, they had to pass a certain amount of classes. I think they had another reminder here, which was that if you take 12 credit hours, you could take any more credits after that and it's free, right? So, you know, if they take 12 or 15 credit hours, you're going to pay the same amount on tuition. Helps you graduate sooner. So they're basically just kind of like reminding these students like, hey, you've taken a lot of money out. So if you want to get done quicker, if you want to get, you know, out of here, get a job so that, you know, these loans aren't accruing as quickly, here's some things that you can do, right? So just kind of, I don't know, presenting them with some additional information about maybe you should, I don't know, take less money out or kind of make sure you're getting, make sure you're trying to get graduated, you know, graduate as quickly as possible. So we have this, where was it? I scrolled through it the first time. There we are. So you've got this Y variable, right? Which they're going to look at a bunch of different things. I think one of the things they look at is how much money the student took out in the next semester. They're going to look at how many credit hours the student took the next semester after receiving this letter. And the things they're interested in is, well, did you receive the letter, right? Were you at Montana State? Or did you just go to Montana State? Did you go to Montana State and receive the letter, right? You're just multiplying those. We talked about those interaction terms. And then, did you receive the letter? Did you go to Montana State, and was it the year 2012? And so when I say receiving the letter here, it actually doesn't necessarily mean they received it, because the reason why they included this year of 2012 is the year before, in 2011, they identified who would have received the letter, but they didn't send it out in 2011. So they only sent it out in 2012. So by kind of controlling for, were you just eligible to receive the letter, the only people who actually received it were people in 2012 who were at Montana State. And they included people from the University of Montana to kind of have like a good control group, right? It should be that, you know, their student bodies look very similar. And so, you know, even though they didn't receive the letter, if it was someone who was eligible to receive it at the University of Montana, I'm now kind of controlling for and able to see what they do as well. So the real thing that we want to focus on is this kind of beta 4, which is, was it a student who received the letter? Were they at Montana State? And was it the year 2012? Because that was the year they actually received the letter. And they controlled for like some demographic stuff, how many semesters they had taken prior, their, you know, how much their loan amount over the tuitions, non-loan aid, the number of credits they had taken, and then kind of whether or not they had a Pell Grant, right? So they tried to include a lot of control, you know, additional controls here. And then we kind of go down here. So here's where it's kind of a pretty interesting effect. So if I look at, right, this was the coefficients that we were interested in. Did they receive the letter? Did they go to the school where the letter was sent out? And was it kind of past 2011 where they were actually sending these letters out? Okay. So when they sent that letter, the loan amount, so these are the different Y variables. So each one of these columns, a lot of times we'll see this in an academic paper, represents a different regression. So they all had the same controls here. It's just we were replacing the Y variable. So here the Y variable was the amount of loans they took out. Okay. So I think if I remember right, it might have had like a log specification. So I can't, this isn't a dollar amount. Like it's not like they took $1.3 less. I forget what the units was, and it's not overly, I don't want to waste a lot of time on it, but we'll kind of just focus on the sign and the significance. So the students that received that letter, right, the loan amount that they took out went down, and we could say we can reject the null, right? It was very significant. Whether or not this was a 1-0 variable for if they took a loan out, did the amount of loans that they took out, you know, fall? So they were more likely to kind of be a 1 here, to have a loan amount that fell. Their GPA actually went up the next semester, so maybe they kind of had kind of this fire lit under them maybe a little bit. Interestingly enough, they didn't take more credits the following semester, which that was one of the reminders that the letter had. And then, are they more likely to kind of choose a STEM major? So they put a plus in here. We usually can go to the footnotes to kind of see what these different things mean, right? So the plus sign here, they report it as 10%. This isn't usually like a conventional line. I told you last class, usually it's 1, 2, and 3 stars. Here, their positive sign is going to be 10%, 1 star is 5, 2 is 0.01, and their 3 is 0.001. So they wanted to be able to show a lot of these things are highly, highly significant, right? It just so happens that whether or not you chose a STEM major, that wasn't impacted as high of a significance level, right? So this was just significant at the 90% level. Okay. So it looks like just getting a letter that reminded students of how much money they'd taken out already, decreased the loan amount, potentially increased their GPA, and even altered major choices. So we look a little bit deeper into this. I'm going to go down here. All right. So the effect that it had on all students for their GPA was pretty significant, right? And it did increase the kind of number of credits that these students were taking the following semester. And it even more so really where that effect, it looks like it's not as large. But if we look at only freshmen, right, those effects were a lot higher, right? Receiving that letter meant that a freshman's GPA, so this would have been, they received a letter their freshman year, their GPA was 0.1 higher, and they took 0.68 more credits. So it looks like maybe it was altering them to take a few more credits, knowing that it wouldn't cost them any additional money. And we can look at some other results that I thought were interesting were, where's the major choice one I thought was really interesting. Did I already pass it? Oh, sorry, that's a different paper. Here it is. All right. They broke it down by kind of different demographics and different things, but really kind of the ultimate story was it was robust to a lot of different specifications. And if we go down here, oh, I thought they had the table. Now I might be thinking it might have been a different paper. Thinking a different paper, they break it down a little more. Maybe we'll look at that one Wednesday about not just were they more likely here to take a STEM major, but investigate a little bit more about which majors they actually selected into. So we'll kind of keep using this same idea to start off class on Wednesday. I'll post up another paper that was related to this kind of what level of loans that students were taking out, but explore a little bit more about their major choice, right? And so the interesting thing about this was receiving this letter, like we were controlling for demographics, their previous academic performance, what semester, what year it was, what school they attended. So we're comparing two otherwise identical individuals, but one of them receives the letter, they were more likely to take out fewer loans, take a higher number of credits, more likely to kind of switch their major to STEM, which is like, very interesting if the power of just sending, someone a letter could do that. Okay. I'll probably end it there for today. Like I said, we'll pick up on the other paper that's related to this one on Wednesday. Work through a few more linear regression examples, just getting more practice with interpreting, probably just hearing me say more of the same thing, but seeing different types of examples. So we'll do that Wednesday and Friday, and then we'll kind of start doing some more review stuff for the exam next week, okay? Any questions from you before we kind of end here? Okay. And it'll be Wednesday and Friday at 1. The Zoom meeting should show up there now for kind of the next 2 weeks. They'll all be at our kind of normal time of 1 o'clock. All right. I'll see you guys on Wednesday.